Good morning, everyone. Welcome to the Electrical Engineering Department at the Technion. My name is Tzachi Birk. I'm a faculty member here, not in your field. And I've been asked to play a strange role. There's always the problem of who introduces the first person. So in computers, we call this bootstrapping, like pulling yourself by the hair. So I am the designated introducer. So again, welcome. It's a very good day. There's a general strike in Israel. The weather is bad, so this is the place to be. And with this, I'd like to introduce Professor Adam Schwartz, our dean, who will welcome you formally. You say, I'm informal.
Good morning and welcome. I think the purpose of the formal welcome is to tell you things that are either not interesting or not new. So I'll try to diverge from this. Today, in addition to being a day of a strike, is the Jewish New Year for the trees. And if you walk outside, you'll find that this is a very green campus. I think there's nothing like a combination of a green campus with great science. So I think this is a good start for this conference. So now I think I can move into the new but boring stuff. So I'll tell you a few words about our departments, and then I'll leave you for the interesting stuff. So we are a research and education faculty. I think what is a little bit unique about this university, the Technion in its vision has cooperation and support of industry as part of our mission. And we are otherwise a technological university that tries to be as advanced as possible. We are a small department in terms of number of faculty, very large department in terms of number of students, especially undergraduate students. And we cover a very large, very broad spectrum of research, all the way from computer engineering, biological. We actually have a laboratory for biological networks where we grow brain cells and microelectronics, solar cells, and also a lot of theory that is very common in electrical engineering department. In particular, our department is a leading department in information theory and other theoretical areas of computer for electrical engineering. There are many research centers here. The first you'll probably be more familiar with. The first two have to do with microelectronics and nanoelectronics. They've been here for quite a while. And I would say that a very large part of industry in Israel that has to do with microelectronics started in this center around the 80s. And Yael had a serious role to play in that. One more thing you may not know, if you use any kind of compression on your computer, Lempel and Ziv are the people that invented the most widely used algorithm. Jacob Ziv is still active here in this department, and Abraham Limpel in the computer science department here at the Technion. The cooperation with industry has many facets here, but I would say that the most effective one comes from our graduates. The undergraduate students that leave this department started I would say about 70% of the high-tech industry in Israel. If you go to Israeli companies that are traded in NASDAQ, most of them were either founded or are run by our graduates. And I think this is our most important contribution to this country. So I think with that, I'll thank you for your attention. And I would leave you for the interesting stuff, which is the TeraTOP workshop. Welcome to Israel again, and enjoy the workshop.
It is a great pleasure to welcome you here at our home, the Electrical Engineering Department at Technion, Israel Institute of Technology. Approximately 40 years ago, the infrared activity in Israel started here in this faculty. Today, it is a magnificent industry in Israel. I was very fortunate in my professional life to be part of this activity. And here at the corner is the father of Ofer Lapid, and he remembers me 40 years ago. In the beginning of the 21st century, a new era, infrared era, has started in Israel. The era of the uncooled infrared sensors based on MEMS technology. Currently, in semiconductor devices, the Israeli National Sensor House uncooled infrared imagers based on the Honeywell bolometers are produced, and I believe offering the best imagers of their kind worldwide. In 2003, we invented here at Technion what we call the TMOS. It is an uncooled infrared sensor based on 3 technologies: CMOS, SOI silicon on insulator, and MEMS. Nowadays, Technion is commercializing the TMOS. In 2008, we extended the CMOS SOI NEMS, it is now NEMS, nano-electromechanical systems, to terahertz imaging. And we call these sensors TeraMOS, the TeraMOS. In 2008, IBM Haifa Research Labs recognized the potential breakthrough of the TeraMOS, and we were awarded the IBM Faculty Award for that. And I want to thank Dr. Israel Berger for that. Since then, IBM and Technion have been collaborating on this, and now under the leadership of Dr. Daniel Ad. One of the fruits of this collaboration has been the establishment of the TeraTOP consortium. The TeraTOP consortium includes 5 distinguished members, not 5, several distinguished members from Germany, EADS, 2 IBM laboratories, Haifa Research Labs and IBM Zurich, CESEM, Center Suisse de Microelectronique from Switzerland, LETI, the National Laboratory of France, and last but not least, I forgot University of Wuppertal from Germany, and last but not least, QMC from the UK. Okay. In 2011, TeraTOP, the consortium, won a very competitive call of the European community, Disruptive Photonics, and we recently celebrated our kickoff at Zurich. Today we will not present you with the new, with the exciting TeraTOP results, but I promise in the next seminar we'll do that. Today we came here to listen and to learn. 5 prominent scientists from the USA, from Europe, and from Israel will share with us their deep knowledge in important fields relevant to terahertz imaging. I am sure that we will have today a profitable and interesting day, but I also hope that out of it, a common ground for the terahertz community will be established both in Israel and in Europe. Before inviting to welcome us Dr. Nicolas Blanc, the TeraTOP coordinator, I want to thank all the people who made this seminar possible. First of all, I want to thank the Dean of the EE department for hosting us. I want to thank my dear friend Alex Gordon from the Technion Liaison Office, who has been a great help all along. Dr. Moshe Harel, the advisor, the TeraTOP management advisor, and obviously, I want to thank the electrical engineering staff, Yoram Amorchen, and all the other people who help us here. And last but not least, I want to thank Miss Susie Eid, who has corresponded with most of you. She's the one that actually made it all possible. So thank you, and Nicola, please, I invite you now.
Okay, ladies and gentlemen, good morning. My name is Nicolas Blanc, and I work for the Swiss Center of Microelectronics and Microtechnology. In short, CSEM. It's very difficult to pronounce, but yeah, CSEM. Very shortly, CSEM is a research lab. We focus on applied research and development. It's a company with 400 employees. And we are working in different domains, but I will mention mostly two domains. One is in microelectronics, mostly low power, wireless interfaces and networks, and based on CMOS also image sensing. This is one big part. And a second, I think, very interesting element is we are also very active in the domain of MEMS. And maybe just a short reminder, the company was funded in the 80s. At that time, Switzerland had a very difficult time. Somehow we believed in the mechanical watches, but we have some difficulties in thinking that electronic watches will be a success. And we missed that train. And today, well, 30, 40 years later, I'm kind of pleased to see that using silicon as a material, not only for microelectronics, but silicon as a MEMS material, we are today able to produce MEMS parts such as spirals and further elements which can be found in very expensive Swiss watches. So silicon has made it also in mechanical watches, just as a reminder. Anyway, today I'm here in a completely different position, and it's a very, very great pleasure for me to be here in Israel. It's due to my responsibility as a coordinator of a European project. The project was mentioned by Yael just 2 minutes ago. It's the project TeraTOP. This European project targets the development of novel, passive, and uncooled terahertz sensor. I think it's a very, very challenging project, and I'm even more convinced. We have spent 40 hours, well, I exaggerate here, but 2 times 10 hours over the last 2 days with the whole consortium, and I realize how tough and how challenging the project will be. But nevertheless, we want to achieve, again, high performances based on uncooled, passive terahertz imaging. And one of the novelty is that those sensors will be realized using standard or CMOS technologies and MEMS post-processing, so really using batch processes, such that at the end of the day, we should be able to realize also rather low-cost such devices. We will not be able to report today on that project. To be honest, we started only last October, so give us a few months more to be able to report on that. Yes, we have 8 partners in this consortium, and out of those 8 partners, 2 are here in Haifa, so IBM, Haifa, and Technion. At this point of time, I just would like to very warmly thank again Professor Yael Nemirovsky and Technion for organizing this seminar, for hosting us today here. I'm convinced this will be a very, very interesting moment, a very interesting seminar, and a pleasant day for all of us. I'm looking forward to those different presentations and wish you a very good day. Thank you.